Hello, and welcome to another session of Excel Programming for Clinicians with me, Dolores Callum. In this session, I will introduce you to some simple variables. Now, I like to think of variables as bins or buckets into which we can place data for use later in our programs. Variables come in many different types, and I will show you when and how to use each one. We will cover string, date, and Boolean variables, and I will introduce you to a number of numeric variable types, including integers, long, double, and single. We will then take a look at two interesting types of variables, the variant variable and the constant. We will then talk about variable scope and when and where you can use your variables. Finally, I will show you some conventions for naming your variables. Okay, let's start our exploration of variables by looking at the string variable. Now, as I've mentioned before, variables are like bins or buckets or even placeholders that you can put some value into for use later on in your program. Variables come in different types, as we've said, and you need to use the right type for the right value that you're trying to store. So string variables store any sort of text value that you want to put into them. You first have to declare your variable before you can use them. So the way you declare a variable is you use the keyword dim. Dim is short for dimension, so you're dimensioning a variable. But I like to think of it, and you can think of it as declaring something in memory. So you declare your variable in memory and you give it a name. So for instance, if I want to store all my patient names, I can declare a string variable called patient name. Then I need to say what type of variable this is. So I need the word as, and then I will say string. Now I've declared a variable here called patient name, and I've set its type to string. Now I can assign some value to this variable. So I can say something like I can assign it a value. And having assigned it a value, I can then put it into Excel using our range object that we are now very familiar with. I'll call the value property on the range object and I'll set it to my variable. So notice that the variable here doesn't say Duluthson, it's just the name of the variable, but I've assigned Duluthson to that variable. So I should now be able to extract its value and put it into the value property of the range object. Let's run the code and see what we get. And as you can see, it's assigned the value from my patient name variable into Excel. Now, one thing to be very careful of is to always make sure when you're using a string property, the value you assign must be enclosed within quotation marks. If you don't get that, Excel throws an error. Let's comment out this code and I'll explain what I mean. I'll copy that into clipboard. I'll comment out the code and I'll paste it back. And then I'll remove the quotation marks. Let's see what happens when we try to run the code now. As you can see, Excel throws an error. So whenever you're using the string data type, you must remember to enclose the value in quotation marks. Okay, let's look at the date variable. Date, as the name implies, is for storing any sort of dates. Let's declare a variable. So I've used the dim keyword to declare my variable in memory. I've given my variable a name and I've said what the data type is. I am declaring this as a type date. Now I can set the value. Now notice that for my date variable, I'm enclosing it within hashtags. This is slightly different to string variables where I enclose them within quotation marks. So for dates, the best way of assigning a date is to enclose it within hashtags. Having declared my variable and assigned it a value, I can now use it in Excel. Let's run the code and see what we get. And as you can see, that date of birth value has been placed in the cell for us. Now, having said date variables should be enclosed within hashtags, let's see what happens if instead you enclose them within quotation marks. So I'll comment out this line of code and I'll change the date value from being enclosed within hashtags to being enclosed within quotation marks. Let's remove the entry from Excel and let's run the code and see what happens. As you can see, it does enter the date. So Excel is able to force a value that's presented as a string, as long as it's in the right format, into a date variable. But I wouldn't rely on this routinely. My advice would be not to use quotation marks for dates, but instead to always use the hashtags. Let's do one more thing. Let's see what happens if you don't use quotation marks or hashtags. So I'll comment out the old code. I'll put the values in again, and now I'll remove the hashtags. Let's delete the value from Excel, and let's run the code and see what happens. As you can see, Excel enters a value, but it's not the value you expected. So presenting date values in the right format is very important. Next, let's look at Boolean variables. Now, Boolean variables allow you to hold any Boolean value. So anything that's a true or false, or a yes or no. To declare a Boolean variable, we use dim, we give the value a name, and then we declare it as a Boolean. Having declared it, we can now assign it a value. Let's insert that into Excel using a range object and setting the value property. Let's run the code and see what happens. As you can see, we entered false. Now, what are some of the other ways to assign values to Boolean variables? Let's take a look. I'll copy that to my clipboard and comment out the code. And this time, instead of setting it to false, I'll set it to the value 0. Let's remove the value from Excel. And let's run the code and see what happens. As you can see, it enters the value false. In Excel VBA programming, every time you're assigning a value to a Boolean variable, the integer 0 always equates to false, and any other integer value equates to true. Let's look at some of the other ways you can assign false values to Boolean variables. Let's copy that to clipboard, comment out, and use the same entry again, and this time I'll use the word false in quotation marks in the same way as we assign string variables. Let's remove the entry from Excel and run the code and see what happens. Again, you see that it worked. Excel VBA is able to accept a string variable as long as it's in the correct format. It correctly spells out false or true. Excel VBA would accept it and assign it to a Boolean variable. What happens if you use anything other than true or false? Let's take a look. We'll copy that code, comment it out. We'll use the same structure again, and this time, let's use something else. No, for instance. Let's run the code and see what happens. This time, Excel does not accept it, and you get an error. Type mismatch. So the value you're trying to enter doesn't match a Boolean. And Excel is not able to force it into a Boolean the same way it was able to force the string, the text value false, into a Boolean. It's not able to do that with any other piece of text. So we've seen a few examples of how to enter false. Let's take a look at a few examples of how to enter true. I'll copy that to clipboard, comment it out. And the way you assign true values is you just type in true. Let's run that code and see what we get. And as you can see, the value true has been assigned. Now, in the same way as we did for the value false, there are other ways to assign true to a Boolean variable. You can assign any integer. Usually, we tend to use 1 for true and 0 for false. Let's run the code and see what we get. 1 equates to true. Again, as we saw before with the false, we can assign a piece of text as long as it spells out true. Let's run that and see what it looks like. There we go, the value true is assigned. And just as we saw before, any other value that doesn't equate to true or false cannot be assigned. We run the code and see what happens. Excel blows up, it cannot match the type. Next, let's take a look at integer variables. Integers are any whole number from minus around 32,000 to plus 32,000. Any number within that range, including the number 0, can be assigned to an integer. Again, to declare an integer, we use the dim keyword, and we give our integer variable a name, and we declare it as an integer. Having declared the variable, we can assign it a value, and we can enter that value into Excel. Let's run the code and see what the result looks like. And as you can see, the result has been entered. What happens if you try to assign a number that's not a whole number to an integer variable? Let's run that code and see what the result looks like. Excel rounds a number to the nearest whole number, and it drops the decimals. So you have to be very careful assigning values to integers to make sure that the value you're assigning is definitely a whole number. Otherwise, you might get unexpected results if you use them to do calculations, for instance. Now, what happens if you try to assign a piece of text to an integer variable? Let's run the code and see what happens. Excel blows up. Excel VBA is not able to convert a piece of text into an integer. Next, let's take a look at long variables. Long variables are whole numbers, but from around -2 billion to plus. So we tend to use long anytime we're working with integer variables that we think will go beyond 32,000. Most of the time, you try to use the smallest variable type that can hold the data that you want to work with. So if you're working with data that's less than 32,000, that falls within the -32,000 to +32,000 range, declare your variable as an integer. If you're working with any whole number larger than that, declare it as a long. Again, to declare your variable, you use the dim keyword and you give your variable a name. And you declare that as long. Let's assign the variable a value. And let's import that value into Excel. Let's run the code and see what we get. And as you can see, that value has been assigned. As I said, any value greater than 32,000 should be assigned to a long. What happens if you try to assign a number greater than 32,000 to an integer? Let's take a look. Declare the new variable, local population. I'll comment out this code. And I'll assign that to 10 million. And I'll try to insert that into Excel. Let's run the code and see what we get. As you can see, we get an overflow error. The number 10 million is too large to be assigned to an integer. Next, let's take a look at the double. Double is used to hold any large number, any large decimal number. So anything with 15 significant digits. So by that I mean 15 digits either in front of or behind the decimal place, but 15 in total, where those 15 numbers are significant and we don't want those numbers to be rounded up. So up to 15, you assign to a double. Let's declare a variable. And let's assign a variable a value. So I've assigned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 significant values. Let's insert that into Excel. Let's run the code and see what we get. As you can see, the value we entered hasn't been changed. It's exactly as we entered it, with a lot of zeros added at the end. But all 12 significant figures have been maintained. Okay, so at the moment we have 12 significant digits. What was to happen if we were to comment out this code and add it again, but this time have more than 12? 13, 14, 15, 16, 17, 18, 19. Let's run this code and see what happens. As you can see, it's been forced back to 15 digits. In fact, even in my declaration, it's been forced back. The 15th digit has been rounded up. And so it's been forced back into 15 digits. So once again, we use a double whenever we have a number that we want to assign to a variable, and that number is a decimal place and can have up to 15 significant digits. Next, let's take a look at single. The single variable is for small decimal numbers. So up to 7 significant digits. So you use it in a similar way to the double, except it can only accept up to 7 significant digits. The reason we need to be mindful of these number of significant digits is because Excel will round up any digits beyond that. And so we want to be careful if we're doing careful calculations that depend on these. Let's declare our variable. And let's assign it a value. And let's enter that value into Excel. Let's run the code and take a look at the result. So only the first 7 digits of your single variable are significant and should be used. What happens if we try to assign more than 7 digits? Let's run that and see what the result looks like. Again, only the first 7 digits are significant, and any digits beyond that cannot be relied upon. So as before, if you have a decimal place to assign and it's a small decimal place, use a single variable. And if it's a large enough decimal place, use a double. Next, let's take a look at variant. Variant can take any value. If you declare a variable as a variant, then it can really be of any data type. You declare a variant by giving it a name and then saying it's of type variant. You can then assign a value and insert that value in Excel. Let's run that and see what it looks like. And as you can see, I was able to assign a string to my variant variable and publish that into Excel. So as I said, you can assign any data type to a variant. So let's try something else. Let's comment out this code. And instead of a string, let's assign a number. Now let's run the code. As you can see, it accepted a string to start with, and now it's accepted a number. Now you might be asking, if you can declare a variable as a variant and then assign any type of data type to it, why do we bother using the different data types, string, date, boolean, etc.? The reason is we want to protect ourselves from either ourselves or our users providing us with the wrong type of data. If you're expecting a date and somebody was to provide you with a number, your program could blow up. So you want to guard against that by having the most restrictive data type for any data you're expecting from either a user or an import or even from yourself. You declare the variable to be restricted to the type that you need so that you know as early as possible in your program as it executes, you know if something is wrong and you can react to that. If you assign it to a variant type, you don't know something's wrong till the very last minute, till it blows up on you. Or even worse, it doesn't blow up, but it gives you an unexpected result and you don't notice the error. Having said that, let's continue looking at the different ways you can assign values to a variant data type. You can assign a date. Let's run that and see what it looks like. And that works. Or you can assign a Boolean. And that works as well. Next, let's look at a constant. Constant, as you might guess from the name, accepts a value that is not expected to change. So it's constant. At the time you declare it, you assign the value straight away, and then it's then constant from that point onwards. So the way you declare a constant is you use the constant keyword, you give it a name, you declare it as a particular data type, and then you assign the value. So instead of using dim, use the keyword constant, you give it a name. As before, you assign the data type, but then you assign the value as part of the declaration. Once that's done, you're free to use it. Let's run that code and see what it looks like. As you can see, the value is assigned and used. What happens if, having assigned the value, before we use it, we try to change it? So here, we're using the same declaration, and then we're trying to change it before we apply it to Excel. Let's run the code and see what happens. As you can see, Excel blows up assignment to constant not permitted. So constant is assigned at the time it's declared and it can never be changed. Next, let's look at variable scope. Now, so far, we have declared variables and used those variables within a single sub-procedure. Variables are scoped to the sub-procedure in which they are declared. When you declare a variable in a sub-procedure, it can only be used in that sub-procedure, and you can't declare a second variable with that same name. Let's look at this. So here I've declared a variable, and I'm going to try to declare the same variable. If I try to run this, Excel does not accept it. Duplicate declaration in current scope. So you cannot use the same variable name more than once within a given sub-procedure. However, a variable within a single sub-procedure can be used multiple times. So I can do something like this. I can declare my variable and use it once. And if I copy paste that, I can use the same variable again. With a different declaration. Let's comment it and run it and see what we get. So there, my variable is used the first time. And now I'm assigning a new value to my variable and using it a second time. So I can use the same variable multiple times, but I cannot declare the same variable more than once. So what if you have one variable that you've declared in one sub-procedure, but you want to use it in a different sub-procedure? How does that work if a variable is scoped for the sub-procedure in which it is declared? The way to get around that is to declare a module level variable. The way you do that, right at the top of your module, you declare a variable. And by convention, when you're declaring a module level variable, you always put an M in front of the name of the variable. Having declared it at the module level, it's now available to every sub-procedure in this module. So let's comment out this code and assign a module level variable. Let's run this code and see what we get. And as you can see, it's assigned, but now I can use the same module level variable in a different sub-procedure. When I run the code, it still works. Next, we'll look at variable naming convention. There are a few rules when you're naming your variables. Your variables must start with text characters. They cannot start with numbers or any symbols. Your variables cannot have space. Let's look at some examples. You cannot declare a variable with a number as the first character. As we said, Excel does not accept that. Similarly, you cannot declare with a symbol as the first character. Excel will not accept that. You have to declare as text. You will notice that I like to declare my variables with what we call camel case. So the first letter of each word is in capital, and when it's joined together halfway through my variable name, it looks like the hump of a camel. Another way to declare variables is to use underscore. As we said, you cannot use spaces, but you can use underscore. You might see some people declaring variables like this. They'll declare variables, all the variables that are of the same type, on a single line. This is valid as long as all those variables are of the same data type. Personally, I like to declare each variable on its own line. Another thing you might see is what we call Hungarian notation. This is a system in which at the start of each variable name, you put a 3-letter character to indicate what the data type is. So str in this case is telling me that this variable is a string. So if I'm using this anywhere else in my program a long way from where it's declared, I don't need to go back up to the declaration to see what the data type is. I can see from the name of the variable that it's of type string. Again, some people use this, not everybody likes it, but if you want to, it's an option. So for age, you could do it as int to represent integer, or you could just do again, Hungarian notation. So the key basic rules to remember: your variable name must start with characters, cannot have spaces in them, and it cannot start with a number or a symbol. My only rule is to make sure my variable names make sense. When you're busy and you're trying to write a program very quickly, you can write variable names that are meaningless. If somebody was to come back to T1 a week from now, they won't remember what that variable was. You're better off fully spelling out what the variable is, so that when you see it later, you know exactly what it does. Okay, so with that, we've had a very quick whistle-stop tour of the basic and most frequently used variables in Excel programming. There are a number of other variables which we'll come across as we go along, particularly the array variable, which will be very interesting. But for us to get to that, we need to learn a bit more about Excel VBA programming. But for now, we have all the tools we need to continue our Excel VBA programming journey. See you in the next video.